Our notes for today are going to be on page 6, and we're going to talk about something that is called the theory of continental drift. So we're going to go ahead and put that as our title, the theory of continental drift. Now, in the last stop, we talked about how there were different layers of the earth, right? And we talked about how in the lithosphere, that is broken into different plates, okay? And we know today a lot more than we used to. And a lot of what we know now comes from a scientist named Alfred Wegener. He was a German scientist, and in the early 1900s, he came up with some ideas, and one of those ideas was that the continents on the earth have moved and that they are continuing to move. So we're going to write some of that down. His name is Alfred, and it looks like Wegener, but he's German. He was a German scientist. So we actually say we say Wegener. It has a V sound instead of a W. So his name is Alfred Wegener. If you ever hear someone say Alfred Wegener, they're probably talking about the same guy. Okay? So Alfred Wegener, he was a German scientist, and like I said, in the early 1900s, and you've got to think that's not that long ago, a little bit over 100 years ago. Compared to a lot of other things that we know in science, this is still a newer concept and newer information. So in the early 1900s, he proposed the idea that Earth's continents move. And the continents, if you think of like social studies, right? Continents are the big pieces of land. We know North America, South America, Africa, Europe, Asia. Okay, all of those are continents. So he decided to write this into a formal theory. And a theory, especially in science, when we say theory, that's just an idea or an idea to explain something. So he came up with the theory of continental drift in order to explain what he meant by his thoughts on the continents moving. So we're going to write the theory of continental drift. So in that theory, he stated that all of the continents were once connected as one huge piece of land instead of being the separate continents that they are today. So he said all of the continents were once connected as one massive, that means really big, if we put all the continents together. Sometimes it was called a supercontinent, and he actually gave that a name. He called that Pangaea, P-A-N-G-A-E-A. Sometimes you see it spelled P-A-N-G-E-A. Either way, it is pronounced Pangaea. And Pangaea is a Greek word meaning all lands. So he called it that because he was saying that this was when all of the lands were together. So again, that was his first part of continental drift. He said all the continents used to be connected. Now when he's proposing this, he's saying that this was a long time ago, almost 240 million years ago, and that over time, in those millions of years, the continents have now moved to where we know them today, where we see them on a modern day map. So he said that Pangaea split up, so it broke apart, and the continents drifted apart. Okay, so there had to be some kind of movement that was making the continents move to where they are now. Now, since this is a scientific theory, of course he had to provide some evidence, right? If anyone was going to believe him, he had to tell them why. So his evidence included the fact that when he looked at a map, and I think this is actually what gave him the first idea, he looked at a map and he noticed that many of the continents or the pieces of land looked like they could fit together like a puzzle, especially if you look at South America and Africa. If you just took out the Pacific Ocean and pushed those two together, it looks like they fit like a puzzle. So that was one piece of evidence that he had. The continents fit together like pieces of a puzzle. Okay, so they're like little puzzle pieces that could fit together. He also noticed that he studied a lot with fossils, and he saw that there were similar fossils on different continents, say South America and Africa again. And that we know now that there's the Pacific Ocean in between those, but the fossils that he was finding, they were fossils of land animals. So how did the land animal get from South America to Africa across the ocean unless that ocean wasn't there necessarily and those two pieces were put together? So he said that there were fossils that matched across continents. He did the same thing with rocks and the types of rocks and rock formation, and he found that the rocks also matched across the continents. There are similar mountain ranges as well, different landforms that match, and all of this is what led him to believe that the continents used to all be together. Except we had a problem. So problem, okay? The problem was nobody believed him. He was actually laughed at and kind of made fun of because he had these ideas, sure, but he didn't have a reason or an explanation for how the plates were actually moving. And because of that, nobody believed his theory. So the problem was that Wegener could not explain how or why the continents moved. So what he says makes sense. Sure, the continents fit together, and sure, the fossils and the rocks match, but how in the world would these huge pieces of land ever be moving? And so nobody believed him. Since he didn't have an explanation for that, they just assumed that he was wrong. Again, like I said, they laughed at him, and they said there's no way that this could be true. Alfred Wegener actually died in around 1930. So he died having published this theory, but no one believed it. So he died, and the idea kind of died with him for a while. Nobody believed it. Everybody just forgot about it because he wasn't around anymore. And it wasn't until later in the 1960s, okay, so again, not that long ago, maybe 60 years or so ago, in the 1960s, with the advancement of technology and new scientific discoveries, there was more evidence that was found that actually did support these ideas. So later, in 1960s, further evidence supported these ideas. One of those things was sea floor spreading. And you'll probably see other videos about kind of sea floor spreading, because it's really cool to see animations of it in action. But with different technology and like including sonar technology, they were able to see that there is new crust being formed in the ocean, and that very slowly pieces of the ocean move apart and magma comes up and fills that spot. New crust is formed. it moves apart a little bit more, and magma comes up. And so when they had that, that kind of gave them part of the why and the how of how the continents were moving. They discovered what we talked about previously, the convection currents in the asthenosphere, how it has that plasticity that allows it to move. That was the explanation for how the plates, the pieces of the lithosphere, could be moving. So all of this supported what he said. The new technology, the new evidence provided the why. And so later they created something called the plate tectonic theory. They didn't keep his theory, since it really wasn't, when we keep it, as in we still have it, but we had to add to it, right? Because it wasn't complete, because it didn't have the why or the how. So we'll write down here, and the plate tectonic theory was created. Okay, so they used the evidence and the ideas of Alfred Wegener, plus the new stuff they had discovered, seafloor spreading, the convection currents in the asthenosphere, and that led scientists to create the plate tectonic theory, which is what we know and believe today. That theory is supported by pretty much every scientist, every geologist, people who study the Earth. In our notes on the next page, on page 7, we'll talk about the specifics of the plate tectonic theory.